No,
Yes,
must,
Rajat.
everything is good, right? Okay.
Started, sir.
Okay. So I welcome you all to the next class on refraction of light. So in the last class, we have learned about the light traveling from denser to rarer medium and rarer to denser medium and bending of light. And this phenomena is called diffraction. We'll see a few more cases of refraction of light in the presence of a convex lens when an object is placed at different positions on a principal axis. How will the image be affected and what kind of image we'll be getting? We'll also learn about the nature of the image. How does it look like? And then we'll try to solve a few more questions on it. Okay, so I want you all to pay attention to my class so that you will be able to understand clearly. And I want you all to type your answers and questions in the chat box so that I'll respond then and there. Okay, so basically to answer all these questions and understand the refraction of light, what do? We do ray diagrams, right? So this class is very important for you because ray diagrams are so important. In your exams, they'll be giving you so many use cases of these ray diagrams. And then you can continue with the rules that I am telling here so that you'll be able to understand perfectly. So for example, let's say there is a incident ray on this convex lens, which is parallel to principal axis, and the light ray gets bent, right? And it passes through a point on the principal axis called focus on the other side. And that is referred as F. And all the light rays that are parallel to the principal axis will bend the light and will pass through a point called focus point. Okay. Now, if let's say the light ray is passing to the principal axis, parallel to the principal axis from this side, and what happens? Again, it will bend the light, and we see that the light passes through a point on the principal axis called focus on the other side. From now, we'll call these as F1 and F2 for the next coming ray diagrams for you guys to understand clearly. Now, let's say there is a light ray that is passing through the focus point F1, and once it is incident on the light on the convex lens, it gets parallel to the principal axis. Right. So we have seen here in the if the incident ray is parallel to the principal axis, it refracts and pass through the focus point. But if the light ray is passing through the focus point, when it refracted by the convex lens, it will be parallel to the principal axis. Okay, but if a light ray is sent through the center of this convex lens, which is called optic center, what happens? It does not deviate at all. The light ray does not undergo refraction. So whenever if a light ray is passing through the center of the lens, which is called optic center, or if it is passing as a principal axis, directly on the principal axis, the light ray goes undeviated, or we can say it doesn't go refraction. So we can use any of the three rays to draw these ray diagrams. Okay, so let's say an object is placed at an infinity. So if an object is coming from infinity, what do we say? The incoming rays must be parallel, right? So if the incoming rays are parallel, the light rays parallel to the principal axis will pass through focus after the diffraction, right? So, and the image is formed on the F2 point. Where the both light rays meet, the image will be formed there. So the image will be as at F2, and the nature of image will be real and inverted, and the size of the image will be highly diminished because the image is coming from infinity. You see the image is real and it will be inverted and the size will be highly diminished. If let's say the object is beyond C1, it is just the position is what we are talking about. So we categorize our ray diagrams based on the position of the object. Okay. Now let's say until now the object was at infinity. Now it is closed to the center of curvature C1. So if the object is beyond C1, what happens? The light ray will be parallel to the principal axis from the object and passes through F2 after refraction. And another light ray from the object passing through optic center will be undeviated, and the image will be formed after focus point F2, where the both light rays will be meeting. So the image will be between F2 and C2. So all you have to remember, and when you are taking notes, you can write it as, if the object is placed at beyond C1, the image will be formed between F2 and C2. And the nature of the image will be real, it will be inverted, and the size of the image will be diminished. Now, if the object is at C1 point, then what happens? A light ray will be passed parallel to the principal axis from the object. It gets refracted and passes through F2 point. Okay. As soon as it passes through F2 point, there will be another light ray that is passing through optical center, and the light ray will go undeviated, and the image is formed when these 2 points will be meeting. And that will be the image. Image is formed at the point where these two both light rays will be meeting. And the image is formed at a point called C2, which is center of curvature. Nature of the image will be again real, and it will be inverted. You can see here directly, right? The yellow color is the object, and whenever the image is formed, the arrow itself is inverted. So the image will be inverted. And the size will be same. There will be no difference in the size. Okay. Now let's say there is an object between C1 and F1, and one light ray will be parallel to the principal axis, like we have seen, and it passes through F2 after refraction. Same. And then there is another light ray that is passing through optical center, and it goes undeviated, and it will meet at a point beyond C2. Where the both light rays meet, the image will be formed. And you can see here, just see the size of the arrow. So how does the arrow look like? Is the arrow enlarged or not? Yes, right? The arrow is enlarged. So that is why the image will be formed beyond C2, and the nature of image will be inverted, real, and enlarged. Right? So whenever you're drawing a ray diagram, if you forget what is the size of the image, what is the nature of image, don't forget to draw these arrows. When you draw these arrows, just by looking only, you can see that, okay, the size of the arrow is also different, so it should be enlarged. Now, I would like to see if you can answer for this or not. Okay, let's say an object is at F1, and one light ray will be parallel to the principal axis, and the other light ray will be passing through F2 after refraction. Another light ray will be passing through the center of the optic center. And now say, so if this gets undeviated, what will be the image that is being formed? Where will the image is formed? I want you to give the answers in the chat box, and I will wait for 1 minute for you guys to give your answers. So I will repeat myself. The object is placed at F1 point. One of the light ray parallel to principal axis passes through the lens and passes through F2 after refraction. And there is another light ray that is passing through optic center, and it goes undeviated. Okay, so where will the image be formed? Where is the image formed? No, it is not between F2 and C2, Kavita. See here, the image, wherever the light rays are falling, they are going parallel, right? In a way, they are going parallel. Not like parallel, they are not meeting anywhere between F2 and C2. So it cannot be between F2 and C2, right? Yeah, very good, Harish. It will be at infinite. The light rays do not meet. So they are parallel, and the image is formed at infinity. What will be the nature of the image now? It will be real, it will be inverted, and it will be highly enlarged. Why? Because it is forming at infinity, the image will be highly enlarged. Now, another point, another position. If the object is placed between the focus point F1 and between optic center, where is the optic center? It is at the center of the lens. So the object will be here. One light ray will be parallel to the principal axis from the object. It will pass through F2 after refraction, and another light ray that will be passing through the center of the lens, which is optic center, and it goes undeviated. So again, light rays do not meet here, right? But appear to come from a point, right? Yes or no? They are appearing to coming from a point. So if I take these two light rays and join it towards backside like this, then what happens? They both meet some at one point, and that point is our image that is formed. That image is called virtual image. The image is formed on the same side. You won't see the image that is forming on the other side. Instead, you will see the image that is forming on the same side, the either side, this side of the lens. And this image is called virtual image or erect image. Erect image in the sense the of the same one. You don't see an inverted image. Instead, you see an erected image. That means the image will be the same. How the original object looks like, the image also looks the same. You don't see it inverted. Okay. And obviously it will be enlarged, right? You see the size of the arrow there. Is it enlarged or not? Yes, right? It is enlarged. That is what. Next. You understood this, right? Everyone? Once, if you all give me a thumbs up in the chat box that you have understood, I will go on with a few questions. If you have any answers or if you have any questions until now, you can ask. I'll try to answer these questions. So if you have any questions, I'll take 1 minute from now. If you have any questions, we can have a few question session. Any doubts? If you are all okay, you want me to go ahead? Okay, I'll go ahead with the questions. Okay, right. Okay, let's answer these questions now. A light ray passes through a convex lens, won't get deviated. So the light ray passes through what? So that the light ray doesn't get deviated. Is it that it should pass through the principal axis, or is it should pass through the optical center? The question is, a ray passes through a convex lens that won't get any deviation. So the light ray should pass through principal axis, or it should pass through optical center, or both 1 and 2, or 1 or 2. Give me the options in the chat box. Okay, good that it is going through optic center, but I would ask you to once think about it. It is not just optic center, right? Even if it passes through the principal axis, it doesn't get refracted. It goes undeviated. So the option is 1 or 2. Just think. I'll go back here in the ray diagram. See here, if the light ray goes through the optical center or principal axis, just see this diagram and once think. They get undeviated, right? So it is both option 1 and 2. Okay. Now, next question. Paraxial rays are those which passes through dash. Does they pass through center of the curvature? Does they pass through the focus? Or does they pass close to the principal axis? Or all of the above? Which one is the option? Ah, good, Harish and Srinivas. It is close to principal axis. Next question. A ray passing through dash of a convex lens will take a path parallel to the principal axis after refraction. So the ray should pass through center of curvature, or it should pass through focus, or it should pass through pole, or it should be parallel to the principal axis in order after the refraction, in order to the ray to be parallel to the principal axis. Where should the ray should pass through? Good. So it is focus, right? Next question. Rays from a dash are treated as parallel rays. A rays from a distant object, or a 1 meter distance object, or below 50 centimeter, or any object. So rays from any object are treated as parallel rays. So what is the answer? It is not one, Kavita. So it is basically it should pass through focus, only then the rays will be parallel to principal axis. Okay. No, it is not 4. Most of the people are saying 4. I would ask you to read the question once again, because the rays from a distant object are treated as parallel rays. That is because a distant object is treated as a point source, and the light rays that will be coming will be treated as a straight line. So that will be treated as parallel rays. Okay. So rays from a distant object are treated as parallel rays. Good. Next. To get a point size image at f2 of a convex lens, the object should be placed between C1 and F1, or pole and F1, or F1, or at infinity. Which of the following options are correct? The question is, to get a point object size object at f2 of a convex lens, the object should be placed at, is it between C1 and F1, or is it between pole and F1, or is it F1, or should the light ray should be coming from infinity in order for the light rays to converge at f2 point? Good. I see people saying F1. I see people saying F1, C1. You are like infinite. Good. So whoever are saying it is infinite, it is correct. Because rays that are coming from infinity will be parallel to the principal axis, and once they are passed through the convex lens, they will be converged at a point called focus, right? That is what we have learned in the ray diagram. Once you draw the ray diagram and you will understand. Okay, if the object is between dash and dash of a convex lens, we get an erect image. You should be answering this question. This is the very latest question that we have dealt with in the theory class. So if the object is between dash and dash of a convex lens, we get an erect image. I would suggest you guys to stick to the class, and the chat should be only regarding the questions and the answers that are being repeated. So I would suggest you not to talk anything other than out of context. Okay, a few people are saying anywhere. No, how can it be anywhere? We won't get an erect image anywhere, right? So it should be between F1 and optic center, right? If the object is between F1 and optic center of a convex lens, we get a erect image. For those who all said first option, it is correct. You are following the class. And then next question. To get a virtual image from a convex lens having 6 centimeter focal length, the object distance U should be in between dash. This is something that is not to be done anything mathematical. It is just for you guys to understand and imagine. It is all about your imagination. So we are talking here about virtual image and a convex lens, and the focal length of the convex lens is 6 centimeters. The object distance U should be between what and what? It is very easy. I think you should all try this. No, it is not. It cannot be between 3 and 6. So simple here. I will explain. So to get a virtual image from a convex lens, what is a fundamental? The object should be placed at a distance. The object should be placed between focus and pole, right? Or optic center. It should be between optic center and the focus. But what is the focal length of the convex lens? It is 6 centimeters. So we are placing the object between 6 centimeters and 0 centimeters, let's say. But we will be placing the object towards the left side of the image, and towards the right side of the image is our, towards the right side of the lens will be our image that is going to be formed. Yes or no? So there is a sign convention wherein all the values that are being calculated towards the left side of the lens will be treated as negative. All the values towards the right side of the lens will be treated as the positive values, right? So I have a positive 6 centimeters focal length on the right side, but my object is coming from the left side. So 100% is that it should be 100, it should be definitely coming from a negative side. So option 2 and option 4 are wrong. It should be either 1 or 3. Now let's decode. So what is the focal length? It is 6 centimeters, right? So if I put my object at minus 6 centimeters, which is f1 point, I will be getting a I'll be getting I'll be getting a parallel ray, right? My object distance wouldn't be 6 centimeters, right? So I will not be getting a virtual image. So in order to get a virtual image, where should I put? I should be putting between 0 and 6. That will be 3 centimeters, right? That is our first option. So if I put between 0 and minus 3 centimeters, if I put my object there, my image will be virtual image and my image will be virtual image. Because the image will be formed on the same side, right? If it is a virtual image. So first option is the correct option. Now, which of the following is a length formula? So, do you know what is length formula? So, length formula is basically 1 by V is equals to 1 by F plus 1 by V, right? So, that is our length formula. So, which of the following options will tell you what is the length formula? So, please give your answers in the chat box. I will be seeing it. Yes, 2 is correct. But what about 1 and 3? Why are they not correct? Just see. If I take this 1 by u to the other side and take LCM, what happens? It will be 1 by v is equals to u plus f by uf, right? Okay, the length. Okay, Harish. The length formula is 1 by v is equals to 1 by f plus 1 by u. So if I take LCM of this, what will I get? 1 by v is equals to u plus f by uf, right? So first option is also correct. Instead of sending 1 by u to the other side, I'll put 1 by u to the other side, this side only, and bring 1 by f to this side. I'll get the third option. So basically, the answer is all of the above. Okay. You want me to explain the previous question? Okay. So to get a virtual image from a convex lens having 6 centimeter focal length, the object distance u should be in between what? So what I'm saying, the focal length of the convex lens is 6 centimeters. To get a virtual image, my object should be placed between focus and the optic center, right? So in order to do that, my object distance should be less than 6. So what is the option? 0 and 3 centimeters and 0, plus 3 centimeters are the two options that is satisfying this condition. So why it can be plus 3 centimeters? That is because we are coming from the left side of the lens. The left side of the lens is taken as negative and the right side of the lens is taken as positive. So because we are putting our object on the left side of the image, you will get minus 3 centimeters. So that is why it is. Next, what is the image distance for an object distance 30 centimeters before a convex lens having 15 centimeters focal length? So I told you what is the length formula, right? It is 1 by f is equals to, 1 by v is equals to 1 by u plus 1 by f. If I have to do that, substitute the value of 30 and the substitute value of 15 and see which answer you will get and tell me what answer you have got. Okay, it is 15 centimeters. And then I'm seeing the answers. So 1 by v is equals to 1 by u plus 1 by v, right? 1 by f, right? So 1 by 30 plus 1 by 15. So what will be the answer? If you calculate, you will be getting 30 centimeters. How is that? So 1 by v will be equal to 1 by 30 plus 1 by 15. If you take the LCM between 30 and 15, it will be 30. So 1 plus 2 by 30 you will get, which is 3 by 30. But it will be 3 by 30, then why is it not 10 centimeters, sir? You can ask this question. So the point is the object is coming from the left side. So when the object is placed to the left side, we consider u to be minus 30. Right? You should have this doubt. So it will be 1 by minus 30 plus 1 by 15. When you do that, what you'll get? You'll get 2 minus 1 by 30, which will be 1 by 30. So 1 by V is equals to 1 by 30. So V will be is equals to 30 centimeters. So 30 centimeters is the correct answer. Now, which of the following is the lens maker's formula? This is a straightforward question. No calculations needed. So what is the answer for this question? Which of the following is the lens maker's formula? Yes, Bhavana. It is very easy to find the answer from the formula of 2. Yeah. But sign convention is also very important. Without sign convention, none of the formulas will be working. So whenever there is an object distance that is given to you, you have to consider it as minus because you will be considering from the left side of the mirror, left side of the lens, sorry. So what is the lens maker's formula here? It is 1 by f is equals to n minus 1 into 1 by r minus 1 by r2. It is very straightforward question. I would ask you to note this. Ganesh is correct. And moving on to the next question. Focal length of a lens depends on what? Does it depend on n? Depends on r1, depends on r2. By the way, what is n? Even in the lens maker's formula, we have n minus 1. N is nothing but refractive index. N is nothing but refractive index. What is R1? R1 is the radius of curvature of first lens and R2 is the radius of curvature of the second lens. So focal length depends on what? So if you see the lens maker's formula, which is 1 by f is equals to n minus 1 into 1 by r1 minus 1 by r2. So it depends on all, right? It depends on n, depends on r1, it depends on r2. So all of the above is the correct answer. Next, if the convex lenses having equal focal lengths are kept in contact with each other, then resultant focal length becomes what? So what are they saying? If the convex lenses having equal focal lengths are kept in contact with each other, then the resultant focal length become what? Because they are placed together, so what will be the formula? 1 by f combined is equals to 1 by f1 plus 1 by f2. f1 and f2 are same here. So what do you do? 1 by f plus 1 by f, which is 2 by f. Right? So what happens to the f? F combined will be is equals to f by 2. It is half. So you should read the question properly so that you will be able to understand. If the convex lenses having equal focal lengths are kept in contact with each other, then resultant focal length becomes. Once again, I will explain because I think no one understood this. So basically, you are putting two focal lengths and making it as one length. So what will be the focal length of the resultant lens? That is the question. In this question, the formula that is you are going to be using is 1 by f combined. The complete combined focal length 1 by f is equals to 1 by f1 plus 1 by f2. f1 and f2 are equal. So 1 by f plus 1 by f, which is 2 by f. So f combined will be equals to f by 2. That is your half. It becomes half. Next. Which of the following is not lens maker's formula? Lens maker's formula. Which of the following is not lens maker's formula? Okay. I'll say for 1 minute, see how many of you will answer the question. We have just done what is lens maker's formula. So, good. I see correct answers as well. Go. So, yeah, I see correct answers in the chat box. So, two convex lenses having focal lengths are kept in contact, then the resultant focal length of the system is 4.5. So, what will be f? So, this is based on the previous question, just before the question. What did I say? So, the formula is 1 by f combined is equals to 1 by f1 plus 1 by f2. So, what do? in that case? So, so if we have same focal lengths are kept in contact, what happened to the combined focal length? It became half, right? So what should be the focal length of individual convex lenses if it is the case which is reverse? It is the same question, but instead of giving the focal lengths of two convex lenses, here I gave the resultant focal length of the system. Now you have to go back. If two convex lenses have same focal length, the resultant will become half, right? So if I directly gave the resultant focal length to be some number, and if I have to find out the individual convex lenses, what will happen? It becomes double. Simple, right? Straightforward question. So 4.5 into 2 will be 9. So 9 centimeters is the correct answer. Next question. Focal length of a plane mirror is. Yeah, this is very straightforward question. I want everyone to one of you to answer this question. Focal length of a plane mirror is. It is simple. You have a plane mirror, and what will be the focal length? The focal length will be infinite, right? Because there is no refraction at all. There is no reflection at all. So you don't have any focal length there. It will be at infinite. The image will be formed at infinity. But to get a magnified real image on screen from a convex lens, the object should be placed at a distance of what? So these questions come from the ray diagrams, wherein you will have to remember the nature of the object, right? Based on the nature of the object. So to get a magnified real image on screen from convex lens, the object should be placed at a distance. At what distance it will be placed? So it is based on the nature of the image. I see questions, answers coming on. Okay. So simple. So for a real image, one is for sure that it shouldn't be placed between focus and optic center. If it is between focus and optic center, you get a virtual image. So for a real image, it should be beyond focal length, right? Or at least on the focal length. But you need to have a magnified image. Then what do you do? So you should be putting at the more than focal length. Only then you'll be having a magnified real image on the screen from the convex lens. Okay. It cannot be less than focal length because the object will be virtual image, and it cannot be equal to focal length because you'll be getting a similar kind of image. You'll not be getting a magnified image. So once if it is more than focal length, then you'll be getting a magnified image. Next. Focal length of a lens depends on what? What does it depend on? It depends on the refractive index of the lens, or it depends on the color of the light passed through the lens, or it depends on frequency of refracted light, or both 1 and 2. Which of the question is which one is correct? Few of them are partially correct. Good, Nando. 4 is the correct answer. That is because it depends on refractive index that comes from the lens maker's formula. It also depends on the color of the light that is passed through the lens. Why? We know that light when passed through convex lens will have high focal length, and that passes through the then the violet color passes through it in the Webster colors. That is how it happens, right? That is the reason refractive index of the light lens and the color of the light passed through the lens both depends. Focal length depends on both of them. So the answer is 1 and 2. Next question. The focal length of a lens is maximum when dash light is passing through it. So I just revealed this answer in the previous question. So for those who have listened to that, should be answering this. The focal length of a lens is maximum when dash light is passing through it. It is a straightforward question. Should be answering it. I'll be looking for the answers. Give your answers in the chat box. Why is it both 1 and 2, Hasita? So in WebGR colors, red is the first color and violet is the last color, right? So it cannot be both. It should be either one of them. Yeah. Correct, Shobha. It should be red. Red is the light. When red light is passed through, the focal length of the lens will be maximum. Next, the focal length of a lens is minimum when dash colored light is passed through it. So again, so it is violet color, right? Because it is the last color. So from WebGR, from red color to violet color, slowly the focal length starts to decrease. Okay. Another question, very interesting question. A convex lens with focus 6 centimeters is cut into two halves as shown in the figure. The focal length of each part is how much? So it is the same question that is followed by previous question. In the previous question, I told you, right, when I am putting two convex lenses with same focal length, so what will be the resultant? So it depends on the same formula. So what will be the answer? It is a straightforward answer. The answer is 12 centimeters because when they are separated, it will be low. When they are combined, what happens? So that will be 12 centimeters, right? Next, dash lens forms a diminished virtual image always. Always. Which kind of lens will give you diminished virtual image? Which of the following lens forms a diminished virtual image? For those who are saying biconvex lens, just once again remember that you don't get a virtual image always, right? We have learned about real images as well. So think and type your answers. So the answer is by concave lens, because concave lens always diverges and convex lens always converges. And concave lens, because it is diverging, you'll always have a point wherein it feels like the image is being formed from a point somewhere back from the same side. So you'll get a virtual image and a diminished. So biconvex lens is the answer. So focal length of a lens is dash when it is in water than in air. So focal length is low or focal length is more, or is it equal, or is it double when it is in water than in air? So the question is, focal length of the lens is dash when it is in water than in air. Okay, so I'll explain the question at the end because there are questions that are to be solved at the end. I'll explain it at the end. Just remind me. The focal length of the lens is less or more or equal or doubled when it is in water than in air. So basically, what happens? Air is in rarer medium, water will be in denser medium. The focal length will be obviously more, right? Because it will be away from it will be towards the normal. So the focal length will be more. So bubble in water acts as a converging lens or a diverging lens or a concave mirror or none of this. So how does a bubble in water acts like? So bubble in water acts as dash. Good. Simple, right? It acts as a diverging lens. Next question. Rays incident dash move through focus after refraction. So the rays should be parallel to principal axis or perpendicular to principal axis, or should be on focus, or should be moving through curvature of radius, so that it can move through focus after refraction. It is simple. Again, you have to go back to your basics, the first ray diagrams. So where should the rays be coming from in order to move through focus after refraction? Good. Good, Ganesh. So it should be parallel to principal axis. So it is simple. The question is rays incident to dash move through focus after refraction. That means, so when you have rays that are parallel to principal axis, they get refracted and move through the focus, right? That is what we have learned in the ray diagram. So rays incident on dash diverges from a focal plane of a concave lens. So here we are talking about concave lens. That is the reason we are talking about diverging. So rays incident on diverges from a focal plane of concave lens. So just draw a ray diagram, everyone, in your notes of a concave lens, because it is diverging. What if the rays are incident on focus, if it diverges from there, or if it is parallel to principal axis, or if it is making an angle with principal axis being parallel rays, or through center of curvature? No, no, no. Okay. So the answer is parallel rays making some angle with principal axis. So you have parallel rays that are not exactly parallel to principal axis. They are making some angle with principal axis. Then what happens? They get diverged from the focal plane of the concave lens. That is what happens, right? If it is parallel to principal axis, it doesn't diverge from the focal plane. Only because they are making some angle, they will always diverge from the focal plane. Next. A ray of light traveling in air strikes a glass slab at an angle of 45 degrees. Calculate incident angle if the refractive index is √2. So these questions come from a law called Snell's law. So what is Snell's law? N2 by N1 is equals to sin I by sin R. Right? Pretty straightforward question. It is basically N1 by N2 is equals to sin R by sin I, where N2 is refractive index of, and N1 is refractive index of first body, and which is equal to sine of angle of refracted angle and incident angle. So write down everyone. It will be N1 by N2 is equals to sin R by sin I. So we have what is the incident angle? We have to find out the incidence angle, because we know that the refractive angle is 45 degrees and refractive index is √2. So basically what happens? N1 by N2 we have, which is, if we consider ray of light from air, right? In a glass slab, it is √2. For air, the refractive index is always 1. The refractive index of air will be always equal to 1, right? Because it is 1, it will be √2 by 1 is equals to sin I by sin 45. Simple, right? What is sin I? We have to find out what is sin I. And what is sin R? Sin R will be sin 45. What is the answer for sin 45? Sin 45 is equals to 1 by. So when we calculate sin R, R will be is equals to, so simple, calculate in your notes. I'm just giving you clues. So when we calculate, it will be √2 by 1 is equals to Sin r by sin 45. So what is sin 45? So sin 45 is 1 by root 2. Because sin 45 is 1 by root 2, you'll get root 2 into sin r is equals to root 2. You'll get 1. So which is 30 degrees. Refracted angle, the incident angle will be 30 degrees. So that's it for today. And we will solve more questions in the next class.